is new stuff. XPath, what has changed? I will focus only on syntax changes and new operators. So all the function stuff will come later. That is John's part. John, you're still, yeah, you're here. Okay. I will try to hit the 25-minute mark. John, we were asked to stop 5 minutes early. 17:25.
Okay, that's fine.
Okay. The map keyword. Don't we all love it? Who loves the map keyword in front of the curly braces? There's 1, okay, 2, 3, 4. Okay, it's gone.
Optional, right?
It's optional, correct. Alan already pointed out it's optional now. But this means that if you were to put any structure, JSON, that you found somewhere on the internet and put that into a variable, then it will be valid XQuery 4. There's a question. Already, it's like the second slide.
When you're using XPath embedded in XSLT, those curly braces are often a value template for attributing text. How do you make that not ambiguous?
Because there's a different context, then they're always. So the question was, doesn't this introduce an ambiguity because of value templates in XML and XSLT? Yeah, so different contexts, different meaning. You cannot do that. There will never be a map in those contexts.
I mean, you definitely can have XPath embedded in XSLT.
Yeah. Even more. Yeah, but this is something that John will cover later. Let's not.
Okay.
Okay. So short recap. How do I do lookups in a map with a question mark? So I can use a 1 for a map that has integer keys, and I can do tests for string keys that are in that map, and I can also do this notation with parentheses and have in there a quoted string with, for instance, a space. That's not new, exactly. So I'm picking up that one because it looks a little ugly. And now this is also valid. You can just remove the parentheses and the quoted string is enough for a lookup.
You showed us the use of slash on an earlier slide. Can I do a slash after one of these maps?
Yes.
I can, okay. So slash star.
The question was, can I use a slash after one of these maps? You can when XQuery 4 is fully implemented. At the moment, you can't because there is no implementation that supports this. So someone was trying already. Okay, there's also this lookup. Who's familiar with this one? To use a variable and you can also drop the parentheses from there. There's a question.
Usually you can put multiple values into your property. Can you also do it when it's not parenthesized? The multiple keys can be looked up.
I'm not familiar with that. The question was, can I put, can sequences be in that lookup? I'm not familiar with that.
Maybe you just want the single. This is a simplification for single.
Yeah. So the question was, this is a simplification for singleton?
When you want to access it.
When you want to, yeah, this is a lookup for one property, exactly. We can try this in a moment. This one we can certainly try. Okay, then one of my favorites, how I came to be talking at conferences, the arrow operator. It's just a recap so that we are all on the same side. So it takes an expression and puts that expression. It allows you to have function calls on the left-hand side, and you can chain that way. You can chain function calls that all use the expression as the first input. So the top line is actually translated or is the same as the second line. And so this is a slightly more complicated example using arrow operators. And I hope you can follow along still. So we have the sequence from 1 to 3 that is summed. The sum is, I think, 6. And that is then put into the first parameter of math pow to the power of 2. So it's squared. And in the last step, we have an immediate function invocation, you could say, that then outputs the square of the sum is, what is it? 36. Okay. We could switch the first line or the second line. So math pow is now on the first one, operating on each of the elements to get to the sum of the squares, not the square of the sums. You see there's one specific thing used. There's a question mark in the for each. So this is already harder to understand, I would say. How many of you think that they grasp this? Okay, see 1 hand, 2 hands, 3 hands, 4 hands. Okay, what does the chat say? I don't know. Do we have hands in the chat? Okay, have I lost chat? Okay, okay. So what does this output? Okay, I trust you. I did not try that myself. But you see the red line, the second line. So this is already like the part where most of you would say, okay, this is actually the arrow operator is somewhat cumbersome. And so there's a new operator now, the arrow bang. I call it, I don't know if that's the real name, but I like it. And it operates on each. It just takes the for each away and now operates on like the What did you do?
Comment on the Slack that said, "Are you going to explain the backticks?"
Oh, somebody was taking it, paying attention. Okay, let's go there. Oh, where was it? Which
Please finish.
This is XQuery 3.1. That's string literals, string constructor functions. I actually was expecting that everybody knows them. Okay. Yeah, we will come to this because it will get simpler. This is the way that you would do template strings in XQuery 3.1, and it's somewhat cumbersome because of the 2 backticks and then opening square bracket and for each. So there's even an error in there. Yeah, the first $sign before the curly braces is wrong. Remove it, please, in your heads. No, I'm teaching. No, it was wrong in all of them. Oh my. So where's my editing wand here? Can I do here? This is wrong. Oh yeah, that smudge will now stay there. Oh, I'm sorry. Okay. So this will be our first session, I think, arrow bang. Please raise your hand or give me some kind of indication if you've finished or if you have a problem with it. You found it? 2 solutions? 3? Okay, what does the chat say? I don't have the chat open. This is okay.
Nothing in the chat at the moment, Juri.
Okay, that was like something to warm you up a little. And if you want to see how it looks like, there's the solution right next to it. So here we have.
Really can't read that. Yeah, it's very small.
What do you mean?
See it, then, yeah.
Yeah, but you have it on your own screen. Yeah.
Still,
Even on your own screen.
no.
Oh,
It's just,
John, did you hear this? We need a mobile view. I said this.
I see.
Plus. Oh, plus a lot.
And we're reading.
Can I command plus? Okay, then it's fine. Ah, okay.
But I also, yeah, I'm sure.
Okay, we all arrived here. That's fine. That's great. Let's move on if there's no questions up until here. Okay, so we learned about the arrow bang. So the arrow operator in itself has a few shortcomings. And that is you cannot change the argument order. It is interestingly very much the same as with the pipeline operator in a completely different height level. It's not XQuery, but this I call it Elixir. They also have the pipeline operator, and I'm really proud of it. I talked to one Elixir developer, and he's like, "Oh, look at this," and he's like, "Oh, yeah, looks nice." But so whatever you do, you cannot change the order. But in the first line, you see we now do 2 to the power of whatever is on the right-hand side. So that's nicer. So or has its use cases, let's say. And the second one does the same with the arrow bang, and even with the arrow bang, it doesn't really look nice, right? I have to create a new function, and then, you know. There. Oh my, yes. There's a curly missing.
That's all right. It goes. Guess what it goes.
Yeah, but I mean, not everybody knows where. So let's be clear here. Okay, there's a curly brace missing. Okay. I can just clear all drawings. That's also easy. Okay, cool. So now, XQuery 4 brings you something. Oh, there's more shortfalls first. The right-hand side, so the thing after the arrow, has to be a function call. You cannot do anything like you can do with the bang operator, which is really cool and has really a lot of use cases. So these simple expressions where you just say, okay, add 2 to something. So you don't have to create a function to add 2 to something, which would be likely the functional approach or something. I don't know. But yeah, as you can see, and here you also see, here's the curly braces are in order, at least. You can do that. So here's the new thing, the pipeline operator. When I first heard about this, I thought, why do we need the arrow at all? Well, yeah, it still has its use cases. But so instead of expression to function, now it has expression, next expression. And the left-hand side will also always be the context value on the right-hand side. It will never operate on each item, but always on all of them. That's the big difference.
Right. Okay. So it goes equals the left right side right equals once.
Yes. Yes. Good question. Thank you. The question was, what's the difference between the pipeline operator and the bang operator? And the difference is, as I just said, that the bang operator will always get each item iterate over the items in a sequence, and the pipeline operator will give you whatever is on the left-hand side, unchanged, passes it. Yeah. There's more questions. The question is, what's the outcome of this? Do you want to guess? 8? I heard 8. I think, yes, 8 is what this is. There's another question?
It's a sequence. It's an array.
Yeah? Then the entire array will be passed. The bang operator will then pass the entire array as well. So there's no difference. The question was, what happens when you have an array on the left-hand side of the bang operator, then the right-hand side will receive the entire array as one. Because in XQuery 3.1 speak, it is just one item. Yeah. Okay. We just had this with the backticks. And now we have it. We have now a combination. There's a pipeline operator that pipes a map into a thing, and this other thing is a string template, not a constructor. And you see the differences are there's only one backtick at the start, and then you can just use curly braces to start any expression inside that string template. And you see the question mark number, what would that be in this? Yeah, this is a 1, so it will output 1. This is one string template, exactly. Now I have to look.
You said that's not a string constructor. What comes out the other side? I mean, if you could put another operator after it, you could keep piping down, couldn't you?
There was a question?
Distinction between template and constructor.
Yes?
What is it?
Less backticks.
What is it? My question you're clarifying? Sorry. If we put another line underneath with a greater, another arrow, minus arrow, what does it receive? A string, right? As a result of that template construction.
What's the result of the pipeline operator? Yeah, that's a string, correct. It will be just a single string.
I'm wondering why it says not a string.
Because string constructor is the one with the 2 backticks and the square brackets, that one.
So it's semantically the difference between a template and a constructor.
Let's look at philosophical.
I don't know if I got your question right.
Don't worry, I don't know enough about the previous versions to understand that.
Your sentence, not a string constructor, maybe too literal. It's a string at the end.
So the
This construction, the usual string construction with the 2 backticks.
Okay, semantically they both use string.
Yes.
okay, the question is the string template and the string constructor both are constructing a string? Yes. They're just doing it slightly differently. And I happen to be in the camp that likes the newer one, the newer version, because I'm used to that. And there are so many languages that do it this way that I will feel right at home. So there is a tutorial on this if you want to join. I also saw that we had actually a slightly more bigger arrow bang tutorial here. Can you see that? Yes, you can. But you can't do that on your own, I think, because we're running out of time already. Oh, yeah. Oh, a lot. Okay. So pipeline operator is here. This is a very simple one as well, really simple one. How to output, how to modify this using the pipeline operator so that you have underscores on before and at the end of test of the string. Okay, let me just show you the solution so that we can move on. Okay, it's now the dot in the middle is the key. And you don't have to use concat. You can also use the yes. So let's try that, because there's a small little catch. If you do that, so one would think that you would just do this, right? Ah, somebody already spoiled it. So if I run this, the context value is undefined. Why? Well, because I need to make this an expression, one single expression, in order to this to run. Okay, so this is something that might be interesting for you to keep in mind when we get our fingers on it. What's next? The FN keyword. There is a new keyword to denominate functions, so that you don't have to type that much, even though nowadays IDEs tend to type for you if you're not careful. But I do like to just write FN. It's fine. You can still use function if you want. It's there's really no difference. There's one small little difference, and that is focus functions. I don't think that I have a exercise for that, but this is something that you will see, so please keep it in mind. There is a new thing. The ID function with a focus function you could implement as this, so you don't have any arguments, and the only argument that you will get is the context value. And usually user-defined functions do not have any context. So this is a very new thing to this. Yeah? So you will never, this cannot never be mixed. Either you have no parameters and then you have a focus function that has a context value, or you have parameters and then you have parameters. So this is also important to keep in mind for later. Okay, 26 seconds for, I don't know how many slides. So let's go quickly through them. If you have questions about them, you can still look at them, and then because there's John. Yeah, right. So we have now braced if, and there's no else. This is new and has its use cases. If you want to just output something, if a condition is true, then you can then add this to your output sequence or return sequence. Okay. This one is somewhat simple, but a lot of people really like it. Is if there is no, there's one, yeah. If the expression evaluates to an empty sequence or false, then the otherwise will be taken instead. Okay. We have switch, and this can now be wrapped in curly braces, something that you couldn't do before. For some reason, I don't know. I'm always writing switch with curly braces and have to remove them afterwards in my code.
That's XQuery.
XQuery, yeah, that's not XPath.
Oh, sorry. So you haven't seen anything. But there is now, in XQuery later on, there is switch with multiple cases. But we can have now nicer type checks. So we talked about consistency. So element, you always couldn't, you could just write either element or element and then the element name. But now you can also say element wildcard. This is weird, but it's new. One would think, because this was, yeah, you couldn't write this in XQuery 3.1.
Push forward out star mean.
It means the same, but nowadays, my brain, I don't have to think, because map star, element star, attribute star, it's always star, 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 and will do the same thing that you would expect. Yeah, and you can also do, obviously, this. And there's this very special thing that you can declare the default namespace is any. With that, when you select diff, you select actually star colon diff. So all the diffs in TI diff, HTML diff, XHTML diff, whatever diff.
Question.
There's a
Put
question.
an as constraint on the function return value.
Sorry?
Can I put an as constraint on the function return value?
Yeah, sure.
And the syntax would be, the as would be before the first person?
As you had before. We will see this. So this is standard. So return value could always be the question was, can the return value also be constrained? And yes, this was always the case, and it stays like this. So union node tests are really, really interesting for me, at least, so that you can say, okay, I want to select all the this and all the sections, and this will make a lot of things easier. I'm just putting it here into the path to denote that is not only for function arguments, but also in path. You can use the same thing because it's union node tests there and there. Okay, choice item types are also really powerful. I've wanted them to write a crossbow back then a long time. That is, this one is a function that allows to pass in maps and arrays, but nothing else. And then I will return the first item of that, like the key one of this, whatever it is. Yeah. Here's destructuring. There's actually exercises for this, but we won't have time for this. Sorry. But even though it says head and tail, so a head will give you. You can run these in the fiddle yourself. There's also exercises if you want to learn what they're actually doing. But head and tail are just names. Yes, so it's just the order of things. When you the first variable will be filled with the first item in the sequence, and the second one, if it's the last one, will get the rest. But if you have a head, middle, and tail, then you would have 1, 2, and 3 in separate variables. Okay. Okay.
Can you embed those? Is that just it's just 2, 3, 4, 5, or can you do destructuring? Like if you're pulling out an array, say, can you put square brackets in that pattern?
Square brackets are coming. This is destructuring a sequence. And you can destructure a map. Okay, there's also, I think there should be an exercise for that. Any questions? Okay, then there's destructuring an array. Okay, and here, this would be interesting to see. I haven't tried that, but it would be interesting to know if you have more than 2 elements in there, what is actually in DOS. I think, yeah, we should try it. Somebody should try it. But I will not want to. Sorry? Yeah, there are map destructuring is in the should be in the fiddle. Let me see. Array destructuring here. And you also can see that I have that there's space like variables for things that I don't I want to discard, and so I have to select them. But let's look at those when you have time for this later on. And this one is the last one. I will not tell you too much about this. We will have a look at this. It's a combination now of a lookup and the arrow operator, where you can pass in context, so a self element. And this will be used later on in XQuery. Okay, John, take it away.
Okay. Right, for those of you, I apologise, the chair is going to be taken out and shot later on. And I'll put it on your own heads. Right, we're going to talk about functions and operators now. And as I said in the original, in the overview, we basically adopted file and binary mode modules. I'm not going to talk about those. We've got 90 new functions and 60 of them extended. We started to use option maps for arguments. They work very well, and option maps as records where appropriate. For these static functions, argument names now become significant because you can call via a keyword. And the real thing is to basically improve the consistency as much as we can over everything. Okay, the first thing is arguments are now optional. We used to define multiplarity functions by multiplarity declarations. but now they're effectively defined as as pieces with effectively optional arguments and default arguments sitting with them in that particular that place. And that's consistent across all the definitions of the functions in the specifications. For many of the higher order functions, things like folds and for eaches and that sort of stuff, it's consistently, there is, if it's appropriate, a sequence position argument is added to the function argument. So you can do things which say, you know, take every, if it's the same day of the week as it currently is, don't do something or something like that. And so effectively, for example, if we take this pipeline, which basically produces the A to Z, and then it filters them based on the item and the position, and we can basically just take, we get basically B, D, F, etc., etc., etc. So this is pretty consistent in all the higher order functions where it is appropriate to talk about the position in the sequence. Okay. Now, as I said, keyword arguments have now become in static functions, not inline functions, generated on the fly functions, but the static function says those names are now significant, and that means you can basically call them with both positional arguments and keyword arguments. Any positional arguments must be at the front, and then any keyword arguments can be in any order, but they must be following it on. And so that is effectively equivalent to a sort where we've got the employee, the collation is now gone to the default collation, and the key effectively has now become this function. And so that's a consistent thing. You've got to be wary of that because you might get occasionally. You have to be aware that that those those names are now significant. The other thing that they've tended to do is where we've got lots of options on a function, like in the CSV to arrays, the CSV thing, which is probably one of the more larger ones that Matt Patterson worked on. Effectively, the arguments now, rather than the string of different arguments, they're all now collected together into a single map. And that map is now defined effectively in terms of a record of a number of pieces, the keys and their options, the values of them and things like that. So, and this, for example, says that each of them, you don't have to have a field delimiter, but if you do, then it has to be a string, etc., etc. And that's pretty much done for anything that's maps, arrays, and for external resources. You've seen this workbench, which we'll use when we get to some examples, so I don't really need to go on about that one. I probably won't be able to get into, but I'll try and get you to do this example, the one on the partition function. So it'll give you something to have a go at. And I should really thank Christian Grün thing, because basically this is a front end bringing all the stuff together to go through to the base X fiddle, which is working very well indeed. Thank you very much. Right, I'm going to do a pass through what these the new functions are, but I know it's going to be very quick. If you've got some questions, put them in the chat and that sort of stuff. But these are the ones on the general new ones on functions. As I said, foot and trunk effectively are the equivalent of head and tail. We've got an identity and a void for when you want basically to pass through an unchanged. You need a function argument, but don't want anything changed. And you want to need a function argument and nothing comes out. We've now got a better mechanism for selecting items from a sequence, for replicating, making a sequence from a replicating, taking a set of adjacent items and putting things in between them, and slicing sequence. And in fact, we've got a step stride, and it can go in reverse direction. I'm not going to go into those things. We've got comparison functions, they're quite simple. You might expect things. Does they contain subsequences? Start with, end with. Duplicate values is a nice one now, because that means it takes the work out of saying, what is this unique? If so, if it's not, which bit values are in there, which was a little bit awkward to do with having to make a compound stuff. And we got some existential all equal and all different quantifiers. Right, we've basically now in the higher order functions, we've got some simple ones like every and some, which produce, again, you check every item in a sequence to get a predicate. Some highest and lowest that basically are sorting, and sorting now by several sort key functions, and sorting by using comparator functions, which means you can do things, you compare them pairwise, and you can do things that you couldn't do with sort keys. But we've also got do until and while do, and I'll show you a do until. There is an example on the fiddle for you to have a look at on that one, but it's fairly trivial. You basically have the starting input. You have an action which computes the next value of the result, and it's got a position sitting with it. And we have a predicate which basically says when to stop. And do while is sort of the flip side of that one. Did I? No, I didn't basically put an argument in there. I don't think you needed one. Yeah. And so, for example, obviously you can do this and end up with an infinite operation. There's nothing particularly guarded about that, but it can be useful where you want to stop in a particular point. We've got other ones. The partition, a take while is again trying to take bits until you fail some particular predicate. And we got a nice one, partition, which is effectively a grouping one, but it partitions an arrays, splitting into a set of arrays when a particular condition is true. So the output groups are now arrays, doing things that you might not do before. And that basically has an input. It has a function which tells you when to split, and it's given the partition so far, it's given the next item, and it's given the sequence position in the whole thing. So you could, for example, use this to partition by into groups of 3 by just working on the sequence position, which is a sort of you could do that in XSLT in a group without any problems. But this one allows you to do things based on this. And there is an example in the that I'd like you to have a go at. Come on. Right. If you go to XPath functions, okay, and you go to partition line wrapping, this is basically, I want you to use the partition function, and you get a link here to the, goes to the, right. No, that's the wrong one, sorry. It's supposed to be a, oh, well that's very interesting. Oh dear, never mind. Right. You can basically fill up, you will do something that splits the line into effectively a set of words, and then a condition on which you want to basically wrap the piece based on a particular length you want to deal with. The rest of the stuff will basically produce the sentences for you and iterate that. So I'd like you to have a little go at putting these 3 pieces together using the partition function. I know what's happened there. It's I'll post a link to the spec for that one. Right. Yeah, so if you could have a go for that, and Juri will give me an idea if anybody's having real problems and when we might like to stop. And of course, if you're really in a hurry, there is next door is a solution which you can go and look at it later if you'd like to cheat.
The first parameter. The first parameter is partition. There's a typo. Partition. Okay, I think now.
Okay, right. Well, let's have a look at the at an answer. Let me just make it a little bit bigger. Okay, so it's fairly simple. We're basically, the input is a string, so we tokenize it, and tokenize now, tokenized against white space by default. So we get a set of words in that line. And the partition function says the sum of the partition which is the set of set of words that we've currently got so far, and the next one. For each of them, basically compute the string length. Okay, we could have used a bang arrow on that one, couldn't we? Yeah, but we don't need to, because that string length basically will take the default context item. So that one basically gives us the character length of all the words if this next one was going to be in place. And the number of spaces we've got is basically the count of the partition so far, because that's the number of spaces we will need between each piece. And if that's greater than length, then we signal that we want to split. So this one will basically split the piece to a sequence of a set of arrays. Each array will be one line, and for each of those lines we pass them through string join, and string join will work on an array because it atomizes what's coming through, and basically we'll put spaces in. So what will happen here is that we will end up with a sequence of lines, strings, each of which is less than or equal to the length itself. And so if we run that, then we get, as you will see here, we get the result. And if we change this to 50 and run it again, we'll get the thing. And that there's an example roughly on this in the spec actually for this partition, which I did a little bit more. I accounted for spaces, and I don't think Michael had done that, but it's very nice. It works nice. It makes a nice change of trying to do line wrapping and things like that. So it's a very simple sort of function that we can deal with, and they'll find lots and lots of uses of that sort of thing. So I'm going to move back to the thing. Right. That's it. Okay. Now we've got a few others. There's a partial apply, which is effectively a bit like the mechanism that we've got at the moment, but it allows you to, it allows you to basically bind arguments that are not in the same order. So it's more flexible. And there's another one which basically will look up an operator and give you a binary function for that. But the interesting one here is transitive closure. I think this is going to make an enormous difference to certain types of problem where you're trying to work out the reach of something through references. And I'm going to basically run this myself for you to get an idea, so you can see what this looks like. Right. Let me show you this example. Right. This is I'm going to take it a little bit smaller for the moment. Right. This is a piece of XML version of the IXML grammar spec, if you like, understand. It's the grammar of IXML in its XML form, okay? But it has some errors in it. And what we can do with here, we're using the transitive closure, is to find out, for example, all rules that cannot be reached from the first rule, and any rules referred to by the reachable set which are missing, and we can do it quite easily and quickly. So I'm not going to basically give you this as a problem. You can go and try it out yourself, but I'll show you roughly what the solution looks like. And if I run it, I get an output that says in here, there's I can't reach IXML from the first rule because the first rule doesn't refer to itself in normal cases, or in this case anyway. And I can't reach an RS because there's no reference to it. And I am referencing an RS1 and a name because but there are no rules that define that. And all I have to do here is basically say it's the transitive closure. Let me make this a bit bigger. Of starting at the first of the rules, and for each of, I've got all the rules. I want to find anything that's got a name, any rule that has a name that's in a non-terminal inside my rule, and I basically follow out. And it tracks effectively duplicates and all that sort of stuff and recursive loops. And that gives me all the ones that effectively are reachable from that first rule. And then the unreachables are all the rules except the reachable ones. And the missings are all the reachable rules and the first rule, every non-terminal of those that doesn't have a rule that it references. And so this becomes much, much easier to try to do these sort of problems that you get in this type of, let's say, parsing and rule generation, following through graphs and inside structural operations. Okay, so let's go back. There are numerical and math functions, fine. We finally got something for isNaN. Basically, is it not a number, rather than having to check, is it the thing that's not equal to itself? We've got string functions, characters and characters. We've got some URI and name functions. You can go back and have a look at these and at your leisure, and you can look at them, but give you an idea what's going on. And things for basically building and parsing URIs and queue names. Other stuff, date, time. Interesting one, siblings, which is basically, it's a function which says it's actually all the children of my parent, which actually includes myself. We've got the other one is effectively deal with maps, and I'm conscious we're beginning to run out a bit of time. The map, it's worth looking at all these things on maps. It's all centered around now a map build function, which constructs from a sequence input using, folks, I'll show that in a second. Other stuff that should have been there, empties, entries, basically producing single entry maps, filtering items and selecting keys, the sort of thing you might expect. And it's just completed, rounded them all out. And so map build, for example, here is input. Sorry, doesn't do highlighting. All right, come on, now we're going to do a previous. We've got an input. We've got effectively a key generation function, and it includes the position in the input as that argument. Something to do what the value should be, and options about duplicates and all that sort of stuff. There is an example in the function that you can try and have a look on that. And then there's another one which is concerned with basically improving the generation of XML structures, JSONs from XML structures. And this is effectively a mechanism that attempts to work out whether, for example, one child has all its children are the same name, or if they're different, as to whether it should be a map or an array and that sort of stuff, and producing plans and that sort of thing. I won't go into that in here. We haven't got enough time to do that one. And arrays, we've done the same sort of thing in terms of rounding out all the different functions, completing most of them. They're all very similar and very coherent, effectively, in doing things like being able to sort them, and basically taking an array and producing its individual members. And remember, the big thing about arrays is that they're the one place where each member can have a sequence. It's the mechanism we use to solve the problem that we couldn't have sequences of sequences. And so it becomes important in this particular sort of case. The JNode functions effectively been covered by Juri beforehand. And we got others for external resources. We're now bringing in something to read an external resources binary in a more general form than the file read binary that we already have, and better parsing systems for HTML and for reading HTML docs and parsing them. CSV, I've said before, and we've actually got a function which creates an invisible XML parser for a grammar. Produces a function which you can then use to parse effectively text against that grammar and produce an XML structure. And that's enough for me. It gives us, we're just after, I suppose it's 25 to 5 for you. And I suspect let's have a 5-minute break, and then we'll get back to XQuery and then XSLT. If that's all right, unless anybody has some burning questions now.
Here's one.
Yep, please.
Regarding those functions, is there any way, is there anything written in the spec that these functions should be part of the base set that must be implemented by all implementations, and these functions are optional because the web doesn't have files?
The question was, is there a set of functions that are marked as optional in the spec, as there are so many, and we have clearly an implementer here who's worried to have to implement them all, even in contexts where file systems do not exist, like in the web.
I suspect that the implementation of the EXPath file and EXPath binary, the EXPath files certainly is an option, is implementation dependent. So there's nothing. The rest, no, I don't think there are very. Correct me, Norm may be able to help me on this one. I don't think there are any that are marked as optional in terms of things. Certainly the what's his name? Yeah, sorry, you can. Certainly the file one is optional.
There's one thing I want to mention here, is that a lot of, like, we saw XSD validator in there, and I'm fighting every time to say, okay, there are non-schema aware processors, and we need to find a solution there, and usually is that we throw an error not supported. That's, I think, current consensus. I hope. Okay, well, I'm stopped for now. Do you want 5 minutes? Should we do 5 minutes?